In lesson 32, we're looking at the quotient theorem of square roots, congruency, and congruent triangle. So on our first example, what we're trying to do is get this fraction so that there isn't a square root in the denominator. So all we need to do is split that up into the square root of 3 over the square root of 7, and then multiply the top and bottom by the square root of 7. So I'll have the square root of 21 over 7, and then we can just leave it like that, because it's considered simplified when the denominator doesn't have any radicals in it. With the next one, we're going to do that same thing and split up the square roots. So in our first one, I'll need to multiply top and bottom by the square root of 5. And then in the second one, I'll need to multiply top and bottom by the square root of 2. So I'll have the square root of 10 over 5 plus the square root of 10 over 2. And then to actually combine these and add them together, we need a common denominator, which would be 10. So I'll need to multiply top and bottom by 2 on the first one and by 5 in the second one. So I'll have 2 square roots of 10 over 10 plus 5 square roots of 10 over 10. And then I can add the 2 and 5 together, so that's 7 square roots of 10 over 10, and that would be my final answer. Alright, and the next one is just slightly more tricky. We're going to be doing that same process, but now we have a number on the outside that's already there. So when I split this up, I'm going to have 3 square roots of 3 over the square root of 7 minus 5 square roots of 7 over the square root of 3. So I just split that up, and I put that whole number on top. Okay, and then on the first one, I'll need to multiply by the square root of 7, top and bottom. And the next one, I'll multiply the top and bottom by the square root of 3. So I'll have 3 square roots of 21 over 7 minus 5 square roots of 21 over 3. And my common denominator is 21, so I need to multiply top and bottom of the first one by 3, and top and bottom of the second one by 7. So I'll have 9 square roots of 21 over 21 for my first one, minus 35 square roots of 21 over 21. Then I'll subtract 9 minus 35, which will give me a negative 26 times square roots of 21 all over 21. That would be our final answer for that one. Okay, the next one is very similar. We're going to have 2 square roots of 2 over the square root of 7 when I split up the first one, minus 5 square roots of 7 over the square root of 2. So on the first one, I'll multiply top and bottom by the square root of 7, because that is what is in our denominator. And on the second one, I'll multiply top and bottom by the square root of 2, because that's what's in the denominator. So I'll have 2 square roots of 14 over 7 minus 5 square roots of 14 over 2. Our common denominator would be 14, so I'm going to need to multiply the top and bottom by 2 on the first fraction, and by 7 top and bottom on the second fraction. So I'll have 4 square roots of 14, and you see I only multiply that 2 to the 2 in front, and that's over 14 minus, then the 7, then multiply by that 5, 35 square roots of 14 all over 14. Then I'll subtract here, so 4 minus 35 is a negative 31 square roots of 14 all over 14, and that would be our final answer. Alright, in example 5 we have two congruent triangles, and we know they're congruent because they have two angles that are equal and each have a side that's equal. So if you were to make a scale factor or a ratio, you'd have 6 over 6, which is 1. So you know that your sides have the same length. So first of all, to solve for x, I'm just going to set this 6x plus 2 right here equal to the 12x minus 4. Right, then I'll subtract the 6x and just go ahead and solve for x like we normally would, add the 4. So I'll have 6 equals 6x, so x equals 1 because I would divide both sides by 6. So I've got the x, and then to find out what p equals, I'm going to put that 1 in place of this x because those sides are going to have the same length. So 4 times 1 plus 1 will equal p. So I'll have 4 plus 1 equals p, so 5 equals p. So I've found x and p.